Hello, welcome. My name is Alvaro Alvarez. I'm here to do this Unity workshop for you today. For those of you that came in person, thank you. Hopefully, you learned a lot. But for those of you that couldn't attend, this is the opportunity for you to go over the same workshop, and hopefully, this will help you get started with your Unity projects. My Let me see. Here's my contact information, just alvaro.alvarez@ucr.edu. So I am the Innovative Media Librarian here. I do a lot of consultations, outreach, and programming around the Creator Lab, the university's makerspace here in the library. We have a lot of cool things, so come check us out. We have 3D printers, 3D scanners, robotics lab, a lot of media equipment that you can use in our media room, the 3DXP lab. And of course, the Creator Lab is the main maker space with all the cool stuff like the 3D printing, the sewing machine. We have a pre-cut, die-cut machine. We have a button maker. Lots of cool stuff. We even have supplies. Some students just come in to use like some of the scissors, screwdrivers, sanding. Also, we have scrap paper, material, things you could use like glue to fix something. That way you don't have to go to the store and buy something if you don't have to. It's all here free to use. For this part, I did create a project in Unity a few years back, like 3 years back, for a course I took. So this is an example of something you can do in Unity. I created a 3D, kind of like a tour of the old makerspace, the way it looked before. There's been a lot of renovations to the space, so it doesn't look like this anymore, but it's similar in layout. If you've been to the Creator Lab, you'll see that the 3D printers are now on the back wall. Those whiteboards are gone. A lot of things have changed. So let me go through this really quickly, and I'll fast forward. So here I'm just talking about some of like the goals. I wanted to bring awareness and outreach to the space. That's why I created this project. I have to go back and work on it some more. I wanted to reinforce a lot of things with the let me go back and let me pause it there. So yeah, I wanted to inform people of the services, educate people on the equipment that we had through the use of the VR. So you can see you can use the VR not just as a tour, but you can also use it as a way to train people on certain procedures. Uh, and I also wanted to reinforce what I learned in the course. So that's why I picked a project like this. And yeah, so like I'll hit play again and kind of fast forward. I did use Blender to create some of my assets when working on this project. Sketchfab, 3D, free3d.com was some other resources that I use for free models for some of the things that I didn't have time to model myself. Of course, now you have generative AI, so you could use a lot of different tools to create assets really quick. Meshy.ai is a really good one. There's others too. Tripo 3D. You could just do text or image as a prompt, and it'll create a 3D model for you. So those are just fast ways to use AI as a tool to kind of get you started. But here, yeah, you could see the creator lab. I have the sewing machine area, the old area for the 3D printing was on the side. And let me move forward a little. And as I walk through the room, you can see the Cricut machines. Those I did in Blender. I couldn't find the model for that. So we also have 3D scanners in the Creator Lab. So you can use 3D scanners also to 3D scan your objects so that you can create a mesh and put them into the VR. I 3D scanned our laser cutter recently and put it into this VR tour. So that's a quick way if you don't know how to 3D model as well. And that's free for you to use as well in the Creator Lab. So take advantage of that. And yeah, so you can see towards the end of it, just a quick example of some of the stuff you can do. And of course, you can make games like old classic games like Legend of Zelda or Super Mario. I mean, your imagination is your limit when creating video games, and also VR games. There's a lot of cool VR games. I use a lot of VR games like for sports, like boxing. There's some tennis ones that simulate really well. So I want to go over the core tools really quickly. That'll be the first part of our workshop. just building the foundation. So Unity Hub, you do need to install the Unity Hub control center on your computer. This is really good for version management so that you can manage your projects really easily in the hub. It'll tell you the version of Unity that you were using. It's very important to know the version of Unity because at every update they change things and your code might not work. It might break links in your project for your characters or your backgrounds, your levels. Stuff might not work. So it's always a good practice to know the version that you're using, and that's when where the Unity Hub comes into play, where you can install different versions of Unity, use them to work on your projects. So yeah, always use the LTS preference. Those are the long term support versions. You want to use those. You can use the other ones too at your own risk, but it's recommended just to use the ones that have the full support. That way, if you have issues, it's easy to find documentation or get help from Unity. And let me see. The next thing you'll need to install is VS Community, Visual Studio. So for those of you that don't do much programming, Visual Studio is an IDE for your computer. So it's like an integrated development environment where a lot of the plugins and stuff you need are pre-installed or you can install manually so that you can start coding and working on your project. In this case, when you use Community, make sure that you check the Unity tools. There's a section, I think, for VR, as you can see on the image. Sorry, it's a little blurry, but make sure you check anything that is for game development in Unity during the install. So that way it'll work really well with Unity. It'll autofill things for you. Communication between both will be perfect. If not, you won't be able to do some of like the IntelliSense stuff or things might not work. So there are two versions of Visual Studio. The reason you want Community is because a lot of the plugins are pre-installed. It's easy to use. It's pre-configured. If you use Visual Studio Code, you will have to install a lot of these things manually. So if something doesn't work, it's on you to fix or find a way. Maybe on a forum or something. You might have to do some research to fix it. With Community, it's kind of like a plug and play, easy to go. You're off and running. Here is a slide if you just wanted to know some of the differences, like the pros and the cons of each. Like you can see for Visual Studio IDE, yeah, it does take up a little more space, a little slower, but it does have it's works for the C Sharp and Python. We will be using C Sharp for Unity, so that's very important. Uh, but yeah, and then the cons, yeah, it's resource intensive. Only runs on Windows, so if you use a Mac, you're out of luck. You will have to use code and then install the stuff you need manually. So yeah, and you can see with code if you need something a little bit more, a little faster, your computer might be a little older. You will probably just want to go with code so that you could just install the things you need. But yeah, here's this visual so you can kind of see the pros and cons and pick the one that best fits for your needs. And here is just ensuring that Unity is talking to VS Code. Sometimes it's not the default editor for your script. So if it's not, when you click on a script or you create a new script and it doesn't open Visual Studio, that means they're not communicating and it's not the default. So you'll need to go to Edit, Preferences in Unity. From there, you do External Tools on the sidebar, and then you want to select VS Studio as your main editor. Then you could just restart the program or hit the regenerate project file, and then you should be up and going on that end. And again, if you have any issues, always email me too. I'm here to help. I can take a look if you have a laptop or email you a video with possible solutions. Part 2, hands-on basics. So here I'm just gonna kind of go over the interface, and again I'll kind of go over these was I'm showing you the stuff in Unity as well. So the interface, the hierarchy, let's see, that's A over here. That's just kind of like similar to if you use Blender, Fusion, SolidWorks. You have your design tree on the left here. It's where you can see what objects are in your environment. You can organize them, create new ones. B is your main area, like your scene view. So, like in any other 3D modeling program, that's where you see your 3D mesh, your environment, your lighting, everything. You also it's very similar to Blender too, the way it looks. So if you've used any of those, it'll be very familiar. C, the inspector, you could think of that as like the conductor that's controlling all the things with that specific object. So like if you click on the cube, the inspector will show you all the properties, all the code, anything associated to that cube. Kind of controls it, like keeps it organized for you. You can change the hierarchy of things. You can put your script on the top, at the bottom. But another way to think about it is like the cube is a watch. And then the inspector is all the little gears and everything that's inside the watch that makes the hands move and able for it to work and keep time. So those are just some simple analogies of this, but lastly, it's not that complicated. So at the bottom you have the D. I labeled the D, the project area. That's just your all where you have all your folders, all your assets, all your scripts. You can organize this as neatly as you want, or just keep everything out in the open. It's up to you. Depending on your project, you might want to be neat and keep everything in folders so you can find things. And here are some of the things that you're going to see a lot when you're scripting, when you're coding in Unity. The mono behavior, that's like a standard thing. This allows your code to interact with game objects. Start versus update. If you've coded in like Arduino or C++, this just kind of shows you like the start is when you initiate everything at the top of the code. Update just keeps going in a loop, updating everything as the game goes on. Variables, those are very important. You have to create variables to control the speed of your character, different aspects of the game. And when you create a variable in the inspector, you will have it'll create like a little slot for it where you can, depending what your variable is, if it's an integer, a float, it'll allow you to control that number so that you can set the speeds or the force or anything that you need in the game. Physics, of course, is very important. Rigid bodies, the colliders are what make the game possible. If not, everything would just kind of go through each other and nothing would happen. The rigid bodies just give your mesh like kind of like a skeletal structure. The colliders are like invisible bubbles around the objects too. That when you're building a game, you can code it so that when two objects meet, when the colliders meet, that something happens in the game. So for this example today, I'm just gonna do a simple rollerball. It's like the hello world for coding, but in Unity. It's just gonna help you understand like how you can control something in the environment, set it up, set a script to it that'll control it. So very basic. And yeah, here are the steps. It's not that hard. So we're gonna create a floor, going to game object, and I'll show you in a little bit in Unity. Then we're gonna create the sphere the same way by going to the game object tab, going to 3D object, creating the sphere. Then you just want to set the position so that it's on top of the plane. And then you add the physics by adding the going to components and adding the rigid body. Again, that adds like that skeletal structure, which allows like gravity and like forces to affect the object in the game. And the code. Um, so here it's very simple code, not that many lines. I think it's like about 10 or 12 lines. This sets up your player controller, your speed controller, and it lets you use the keys on your keyboard to just move the ball left and right and up and down the platform. So you could see some of the things I've mentioned, like the start and using Unity Engine, the mono behavior, a lot of the things I mentioned are here. You have your public at the top, um, and then you have your void start. So very simple code. It's not that hard to comprehend if you read it. And let's see.
Hey everyone, and welcome to this explainer. Okay, I want you to picture something for a second. Imagine you're standing right at the starting line of a massive video game obstacle course. You know the kind, huge platforms, bottomless pits everywhere, and your hands are just gripped super tight around your controller. You push that joystick forward, and boom, your character takes off running. It feels instantaneous, right? Honestly, it feels like magic. But behind that seemingly simple action is an absolutely fascinating, highly structured reality. Today, we're going to break down the actual anatomy of that action by looking at the exact foundational text that makes it all possible.
So it really begs the question, how do you actually tell a computer to take a step? A lot of people see code and just immediately freeze up. They think it's this intimidating, hyper-complex math that requires a genius-level intellect to even look at. But honestly, that's a huge misconception. Today, I want to completely reframe how we look at code. We're not going to treat it like math at all. Instead, we're going to look at it as simply describing everyday physical reality to a machine. When you write a script for a game, you're essentially acting as the ultimate translator. You're taking the physical movements that we just take for granted every single day, like stepping, jumping, falling, and breaking them down into a language that a computer can actually understand and execute. All right, let's kick things off with Section 1, the rules of the world. Okay, let's dive right into this. To get our character to move, we can't just shout "run" at the monitor. We have to start from the absolute beginning. Before our character can take a single step, they first need a universe to step into, right? And that starts with one incredibly simple line: using Unity Engine. Now sure, it might look a little technical with that semicolon at the end, but its actual purpose is incredibly profound. Think about the physical translation of this concept. You can't exactly go for a walk if there's no ground beneath your feet, no air in your lungs, and literally no gravity holding you to the earth. By typing this single line of code, the developer is essentially plugging their script directly into the fundamental laws of nature for the game level. You're telling the computer, hey, we are going to operate inside a reality that actually has physics, lighting, and spatial dimensions. You are literally switching the universe on. Moving right along to Section 2, naming the brain. Okay, so the universe is switched on. The world exists. Now we need an actor to actually place onto this stage. We need to create the intent and the mind that's going to navigate it all. When you type out a string of text like public class player controller, you are explicitly naming your character's digital brain. Those words aren't just random. They're a totally human readable label. It's the developer declaring to the computer, this specific piece of text right here, this is the central nervous system for our player. It's the mind that will eventually receive the signals from your joystick. But what about the second part of that line? Let's demystify the jargon monobehavior. In the real physical world, just thinking about running doesn't magically make you run, right? You need a physical body that occupies physical space. Monobehavior is quite simply the character's VIP pass to step foot into the digital reality. It is the literal ticket that allows this newly named brain to exist, to interact, and to attach itself to a visible object within the game world. Without this VIP pass, our code is basically just a thought floating out in the void. With it, it becomes a fully active participant in the reality we just switched on. Next up is Section 3, setting the pace. So, we've got the universe, and we have a brain with a VIP pass to interact with that universe. Now we need to give our character the physical capability to move at a specific rhythm. This brings us to a line like public float speed equals 10f. This one single line dictates exactly how fast the character's muscles will twitch. It's the numeric value representing their stride, their momentum, their physical exertion. Tweaking this one number is the literal difference between your character taking a leisurely, exhausted walk and going into a full-blown, adrenaline-fueled sprint across the level. That 10F is just the starting baseline we've set for their physical fitness. Now, you'll often see developers use 2 forward slashes to write something like, "This shows up in the inspector." The funny thing is, this isn't an instruction for the computer at all. When a developer types those 2 slashes, they're just leaving a note. It's a human-to-human whisper, right in the middle of all the machine's instructions. They're leaving a little sticky note for themselves or their teammates to explain exactly how this code behaves behind the scenes. And that note specifically mentions the inspector. Think of the inspector as a massive control panel, or like a Hollywood director's chair.
Because we made our speed public in the code, it actually pops up on this control panel. That means a game designer doesn't have to dig all the way back into the complex text to change how fast the character runs. They can just sit in the director's chair, look at the screen, and tweak physical reality on the fly, just sliding the speed up or down until the movement feels absolutely perfect.
Which brings us to section 4, giving the body weight. We are incredibly close now, but there is a final, absolutely crucial missing piece of physical presence before our character can successfully cross a gap or jump over a pit. And that missing piece is declaring a rigid body. Without this specific command, our character is essentially just a floating ghost-like brain. I mean, they might have a speed, they might have an intent to move, but they have absolutely zero substance. If you tried to make them run right now, they would just glide straight through the walls and fall infinitely through the floor. This comparison is so vital for understanding how a game actually feels to play. Rigid body is the exact command that gives the character solid bones, mass, and true physical presence. The moment you add it, the game engine says, okay, this object is solid. It has weight, gravity should pull it down, walls should actually stop it from passing through. You are giving the digital brain a physical heavy skeleton so they can actually land on the ground with a really satisfying thud when they jump. The RB part you see is just a quick shorthand nickname the developer uses so they can easily reference those bones later on. And finally, section 5, ready for the level. It is honestly amazing how much physical reality is packed into just a few short lines of text. The crucial point here is how this sequence perfectly layers upon itself. Step 1, we entered the world and literally turned on the universe. Step 2, we defined the mind and gave it a VIP pass to interact. Step 3, we set the physical capability and the muscle twitch with our speed. And finally, step 4, we gained mass and solid bones. Just 4 lines of code. That is literally all it took to build a complete, structurally sound, ready-to-move character standing at our starting line. We've translated the complex anatomy of physical reality into a language the machine perfectly understands. Which leaves us with this final, kind of wild thought. We've built the anatomy. We've prepared the muscles. We've set the gravity. If just 4 lines of text can give us an entire body and a functioning world, what actual magic happens in the code when we finally push that forward button on the controller? How do we trigger all that pent-up energy into actual explosive motion? That is the true power of code, and it's something I hope you are now incredibly eager to discover. Thank you so much for joining me on this explainer, and keep questioning exactly how the digital world is built.
The next slide, I just wanted to share some things that you can use to further enhance your games or help you develop your games. So we have the asset store with thousands of free and paid 3D models. So some you do have to pay, others you don't. Like I said, this is good for prototyping because once you go in there, you can there's a button that says like add to my assets. So when you click on that and you're logged into the store, it'll kind of just add the asset to your game that you're currently working on. So it makes it easy for you to just simply buy your asset, or if it's free, add it to your library, and then you go into Unity, and it's already there for you. So it makes it really, really simple. And that's the Unity package manager. So that's a really neat feature. Another asset that you can use or tool is the Pro Builder Level Designer. I've used it in the past. So you install this. Sorry, my light goes off. So you install this add-on, and this allows you to. It kind of allows you to build things within Unity in the environment. So you could see in the example, you could build walls. You could build like a whole level really easily. I've used it before, like I mentioned, and yeah, it's really quick if you want to build like a 3D level environment and then add your textures and everything at the end. And if you have any more questions, or I do consultations, so you can use this QR code. I can meet with you 30 minutes to an hour or more, and we can go over the workshop if you need me to, or if you have any other questions as well with Unity, and I can try to my best to answer your questions. So let's see. I should have Unity up. Let's see. There you go. So I'm bringing up Unity now, and you can see I have my rollerball project up and running. Here with the controller on my mouse, I can zoom in with the wheel. If I do middle mouse, I can click and drag the environment around. Of course, you can use this over here, the orientation guide, to click on it and move things. Left click doesn't really do anything. Right click just kind of moves stuff around. So, but yeah, once you get used to this, there's also some other tools down here that you can use to maneuver around. And of course, you can click on objects, and you see over here in the inspector, as soon as I click on the ball, you can see all the properties associated with that asset. So you see I have my script down here that controls the way I can move the ball around, my rigid body, the collider, and a lot of this stuff is default, but you can play around with all of this to get like the lighting and everything. You can turn it off, on, and you can, of course, like I said in the code, I have the line where you make the speed public so you can control it in the inspector, so you can control the speed of the ball. This one only has a collider. It doesn't have anything else. It's just there to keep the ball on top. Solo, that's the only things I have here, and of course the camera. And over here is where you can see what you have in your scene. So your main camera is there. You have the lighting, volume, the plane, and the sphere. And to create new objects, like I mentioned, you just go to Game Object, 3D Object, and here's where you can do. I did a plane for the bottom part, and then the cube. So if I hit cube, you see now I have this cube, and I can move it manually. I don't have to input it in the properties, but if you do know the position, you could go over here and change these numbers so that you could position it where you want. Maybe you do want it up here floating and spinning around, you can do that. Or if you want it on the exactly on there, yeah, you could see it's perfectly, looks like it's on the plane. If not, you can change the numbers to match the ones for this, and it would work. So let's see. I'm going to delete this. I don't need the cube. So the next step is the code. So if I go to assets, you see I have all these different folders here. So I have my scripts, my scenes. Of course, in a game, you're going to have different scenes. And the way that works is when you have a game, you might go to the next level, so you'll have a different scene for that level. So in the game, when you beat the boss or something, that'll trigger the Unity or the code to send you to the next scene. So that's the way the games are designed in different scenes. And each scene contains different assets and properties and everything. So that's why I said the more organized down here, the better. I have your scripts folder with all your code. As you can see, I only have one for the ball, for the controller, your settings, and you could create any folder you need. It's your project, so whatever helps you remember things best, that's what you want to add to that area. So now let's see. I'll show you how I added the code and the rigid body. So to do that, first you just want to click on the object, and anytime you want to add something to your object or anything in your game environment, you want to click on it, and you'll see that changes all the properties over here in the inspector. So I want to go down here, go to add component, and here you can see it gives me all the different defaults, but I want to search for rigid body. So let's see, it's I. So you can see I just need to click on it, and it'll add the rigid body from there. And for script, that one is just at the very bottom, new script. It's hard to see, I think it cuts off, but you could just do new script. When you do that, it creates a blank script. For mine, I named it player controller, added it to this folder. From here, you could just simply double click it. It'll take you to VS community. So here in Visual Studio, you can see I have my code, everything 100%, no issues found. So once you save it, it's ready to go, and you can see the code here. So I can hit play. And since my camera is on the side, that's the view I'm going to get. If I don't like it, I can always go back into the game, click on the camera, and move it to the position that I want it to, since it's a 3D game. Here, I could control it with my keyboard. So you see, I can go left, I can go right. So I'm controlling it with my keyboard, and the ball fell because I got to the edge. And that's where the rigid body and the physics comes into play. So let me see. I'll play it again so you can see. I'll make it fall uh, in front of us. So you see, it just falls off. So yeah, this is the very basics of your game. Let's see. One other thing, maybe if it doesn't work, I am using a newer version of Unity, and I had to make a change. So I had to go to project settings, I believe. Let me see. If for some reason you're not able to control it, you just need to come down here. Uh, so I went to project settings, player, and then over here where it says active input handling, make sure it says both. I believe the new system won't work with the code that I'm giving you. You will have to update the code. It's using the old input manager, so just select both, restart Unity, and that should help you solve that issue. And after that, you should be good to go. So hopefully this workshop really helped you kind of get Unity installed, all the stuff you need for Unity on your computer. Now that you are ready to go, you can play around with this code. Maybe play around with the speed a little so you can see the differences. But yeah, add more items to your game, and just when making a game, you do want to like plan it out. You want to create your assets. Like I said, there's a lot of different ways to obtain them. If you have any questions, feel free to reach out. But once you have all your assets and your story, it's important to have a story behind your game. You can come into Unity and start creating that world or that vision you have of this video game or tutorial. So, yeah, the sky's the limit. So, if you have any questions, again, let me know. I'm here to help. And hopefully, I'll be able to do some more Unity workshops in the future where I'll help you set up sprites and do some more advanced things to help you get further along in your game development journey. So, thank you again for joining me today, and hopefully, see you soon.